Can you imagine living on an icebreaker in the Central Arctic Ocean with an international team of researchers, engineers, and crew working together to study all aspects of the Arctic climate system simultaneously for a full year? Why are scientists studying the sea ice, the ocean, the atmosphere, and the organisms that live there? The Arctic climate system is a complex web of interrelated processes. To understand this system, you have to pay attention to these incredibly tiny details. Even invisible details. And because every detail is connected to others, you need numbers to describe those connections, too. Let's follow one of these connections from the atmosphere down through the sea ice into the ocean and see how we end up back in the atmosphere. The atmosphere is full of tiny particles. Some of these particles, called aerosols, provide little surfaces for water droplets to form on or ice crystals to freeze on, which leads to the formation of clouds. Atmospheric chemist Dr. Lauriane Keeley-Vare is trying to understand how these aerosols form in the Arctic.
I am interested in what is going on with the chemicals that forms aerosols, and then looking at whether or not those aerosols and which ones are important enough to impact the climate.
Atmospheric scientist Dr. Matthew Shoup is looking to understand those clouds better.
My favorite kind of cloud is Arctic mixed-phase stratocumulus. Mixed-phase clouds have both supercooled liquid water droplets and ice crystals. I would like to know, why does liquid water exist at temperatures that are below the freezing point in all these clouds?
Matthew and his colleagues are learning that the amount of liquid water and ice in clouds impacts the amount of sunlight that passes through to the sea ice. The sea ice, layered between the atmosphere and ocean, modulates exchanges of gases, heat, and light between water and sky. To understand the ways Arctic sea ice impacts these vertical interactions, sea ice physicist Dr. Marcel Nicolaus studies the sea ice from below with underwater instruments.
The sea ice is a key element of the Arctic Ocean. It's also that element that makes the Arctic Ocean or polar oceans distinct from all the other oceans in the world. I'm researching how sea ice freezes and melts, how the snow cover on top of the ice impacts the amount of sunlight that passes into the ice and into the ocean, and how much sunlight is there for the animals and plants living in and under the ice.
Atmospheric scientist Dr. Jesse Kremian studies microbes, which are tiny organisms like bacteria or plankton that normally live in the ocean and sea ice.
They don't usually get up into the atmosphere, but I'm researching how that's changing as the sea ice melts and as more of the ocean becomes directly exposed to the air. Now, certain types of microbes have a really special characteristic. They can help clouds form. And so when winds carry them high up into the atmosphere, they can become these tiny little surfaces for ice to grow on and can actually help ice crystals form in Arctic clouds.
Little surfaces for ice to grow on. She's talking about aerosols. Remember those aerosols that help clouds form? That's where we started, and we're back there again. Clouds affect temperature. Temperature affects sea ice. Sea ice and water affects ecosystems, which again affects the atmosphere. A complex loop of cause and effect. There are so many of these loops, so many complex interactions that cut across the Arctic system, and researchers are trying to study all of them together and at the same time.